Tara, hello.
Yep.
I'll do intro and then I'll ask you to give a quick intro on Prometheus.
Pardon?
I'll ask you to give you a quick intro on Prometheus. I'll do the intro and then I'll ask you to give a quick just talk about Prometheus a little bit.
Oh,
What it is.
me.
Yeah. Yeah.
Uh,
Hey,
okay. Now
you
I
wrote
have
something. It's fine. You can just like
now I
share
have
it.
to bring up Prometheus just so I could remember what it's for.
I'll paste what you wrote here on the chat.
The hardest thing about Prometheus is its plural form.
Is it plural? Right?
I can't even pronounce the plural. Apparently it's Prometheus or something.
Prometheus.
Okay.
It's plural, but yeah.
Yeah.
It's a name of I think a Greek character, right?
No, it's the name of a Greek character. A mythical in Greek myth, and also it all happens to be a movie in 2012.
Right.
Yeah, that was a pretty cool movie.
Yeah. Okay. 1 minute, I think, left. Good luck.
Oh wait, that's what I wrote, right?
Yeah, that's what you wrote. That's what I put. Anyway, they can hear us, by the way, so.
Sorry.
Marco, you're on.
Thanks. All right. Good evening, everyone. Welcome to GoManila August meet. Thank you for attending again. So it was nice to be able to get back last month, and then I guess it's we're trying to keep the ball rolling. So expect more meets in the following months. Anyway, so let's get on. So I guess today's topic will be about Prometheus, and basically we have Oliver Powell, who was part of our panel last July, coming back and giving I guess a much more dedicated talk around Prometheus and how you can use it with your Go applications. To give us a little bit of a background, just a quick intro on like what Prometheus is. Charo, can you sort of like talk us through just the high level stuff about Prometheus?
Yeah. So for anyone who's not yet familiar with what Prometheus is, it's actually an application that's used to monitor events, give alerts, and record whatever metrics are there in your system in real time. So the reason why we'll be talking about, or rather our speaker is going to be talking about Prometheus, is Prometheus also happens to be created using Go. Okay. Then another thing is that Prometheus is also a graduate project of the Cloud Native Computing Foundation. So it's pretty much at the level of, say, Kubernetes. Marco?
All right, thanks, Charo. Thanks for that. Yeah. So just to cut short, our speaker Oliver Powell is a senior platform developer at Brankas. In a previous life, he was also a full stack Clojure developer. But I guess these days he has switched to a to functional programming and parents for Go and infrastructure. Right. When he isn't struggling with YAML indentation, he is either running after his small kids or reading about anthro-complexity. He lives in Cape Town, South Africa, with his wife, son, and daughter. All right, so to start with our talk about Prometheus, guys, please welcome Oliver Powell. Thanks, Oliver, for joining us.
Yeah, thanks for having me.
All right,
Cool.
whenever you're ready, man.
Cool. I'm gonna share my screen. You guys see that?
Yep, we can see your screen.
Cool. And you can hear me, right?
Yes, sir. Yeah.
Cool. Okay, so this talk is called Taming Prometheus. It's basically about my experiences running Prometheus at Brankas. Previously, okay, the other title for this talk could be Using Prometheus in Anger. That might explain it better. For some background, I'm from Cape Town, South Africa. That's a city at the tip of Africa, in case you didn't know. Like Marco said, I used to be a full stack Clojure developer, but I recently switched to Go about a year ago. And I'm a platform developer at Brankas. You can also reach me on Twitter if you need to. Cool. So my promise for this talk is that by the end of the talk, you'll know how to run a reasonably lean Prometheus in production. And what I mean by a lean Prometheus is just Prometheus that doesn't eat up more resources than it needs to. And it's not going to run out of memory or run out of disk space. So that's my promise for the talk, hopefully. So here's the outline. I'm going to give a brief introduction to time series databases and time series. Brief introduction to Prometheus. I'm not going to go too in depth because this is mostly about taming Prometheus, not really an introduction to Prometheus. Although it will have some introductory things. And then I'm going to go into like a case study, how we halve memory usage and while doubling our retention time, and then some takeaways and resources. Cool. So just to start off with, to think about time series data and time series databases, you can think of the internet as kind of being inverted. And what I mean by that is the traditional internet's kind of like you've got various monolithic hardware at the center, and it's generally like pushing bits out to a whole bunch of clients. And the workloads tend to be read heavy and update heavy. If you imagine transferring money from one bank account to another, you update the one account and you debit the one account, credit the other account. On the flip side, time series data is the exact opposite of that. Instead of having a bunch of essentially web browser clients querying stuff, you have a whole bunch of things like your watches and industrial machines, self-driving cars, microservices. All these systems are like pushing tons and tons of data into one centralized store so that people can analyze and query it. And in these kinds of workloads, basically writes typically dominate reads and inserts dominate updates. And most of the inserts are generally append only. So there's a immutability factor there that you generally don't go back and update anything. So because of that kind of specialized nature of that sort of data, the world sort of time series data has become really hot right now because it's kind of a hard problem to ingest this much data. And so like the old traditional technologies were designed for a completely inverted use case, basically. So that's kind of why you see a whole bunch of different time series projects popping up like Timescale DB and Influx DB. There's a whole ton of them. So what is time series data? So time series data is basically data where time is the primary axis. And mostly you're doing sort of range cherries on time. So you're saying, give me the events that happened between this time and that time. And then usually there'll be some tags on it. So on the right, I've got like an example of this. So typically you'll have the time, and then these are HTTP requests in case you didn't notice. But usually you'll just sort of have various labels, and usually you'll ask like, give me the HTTP requests that happened during this time that are gets or gets to this particular path, things like that. The important things to note though are that it's append only and it's ordered by time. That's very important. And I took this from the timescale DB blog, because I thought it was kind of like a good way to summarize it. So one thing to notice that log data and metrics all fall into this camp, and there's probably other kinds of data that rely on time as the primary access, but also count as time series data. So this brings us to Prometheus. So Prometheus is a time series database. It's also a lot more than that, but we'll get into that later. It was founded in 2012 at SoundCloud. SoundCloud happened to have, I think, a guy called Julius False, I think his name is, and it was another guy, I forget his name, but basically they weren't happy with the graphite stats-D stack that they were using. I think this was also the time when microservices were kind of exploding, and they found that, you know, the graphite and stats-D just didn't really satisfy their needs. And I think Julius came out of Google, and Google had this internal monitoring system called Borgmon. So they basically ambitiously decided to basically make their own monitoring system in the spirit of Borgmon. And I think many people actually call Prometheus the open source Borgmon. So Prometheus really is aiming to be sort of all in one. So it's got the metric storage, it's got querying capabilities, there's a console that you can do basic graphing, it does metrics scraping, it does service discovery. So if you run this in your Kubernetes cluster, it knows how to query the query kubelet and find all your pods and things like that. And the real emphasis is on the fact, I think why Prometheus became popular was because it is all in one. You literally just download a Go binary, run it, and then you've got all of this like available instantly. There's nothing else to configure. If you contrast this with installing Graphite or Stacks-D, it's like a whole lot of steps to just get it running, and a whole lot of different configuration files. The Prometheus ecosystem, in contrast, is much simpler. So this is what the architecture tends to look like. Prometheus itself, like I said, is the database. It's got the service discovery. It scrapes targets. Prometheus is pool-based, unlike Stats-D and Graphite and other monitoring systems. There seems to be like the split between push and pull, where Prometheus chose pull, most likely because that's similar to the Borgmon design. Prometheus itself, while it has most of the functionality you'd want, you can extend that with alerts pretty easily by installing Alert Manager, which is just another binary that you run. It's also pretty easy to configure. It hooks up nicely to Grafana if you want to have fancier dashboards. The Prometheus console is, I wouldn't say it's really a dashboarding solution. It's more for like exploring your data, not really visualizing. So you'll probably use Grafana if you want proper dashboards. The weakness of the pull-only approach, obviously, is that how do you do short-term jobs? How do you get metrics from them? And so they've got another component called the push gateway, which basically lets jobs sort of send metrics up to Prometheus, because obviously it can't scrape them really. Yeah, and then you've got the service discovery, as you know already. So one important point is that Prometheus is pull, and while the authors say it's kind of close between push and pull in terms of pros and cons, they generally feel that pull is slightly better, and that's because local development is easier. So because you're pulling, the application itself doesn't know anything about the monitoring system. So you could, for example, be developing locally and be scraping like something in staging or production, and it won't really affect anything because you're just scraping the endpoint and the application doesn't know any better. So you can then scrape that data into your local Prometheus, and you know the system as a whole is none wiser. It also kind of makes system checking for services up. It makes that much simpler because it's already part of the service discovery. So every every target that you're scraping has like an up metric already built in. That's kind of easy just to check if the service is up or not. It also makes metrics debugging much easier because you can literally just go to a HTTP endpoint /metrics and see all your metrics. And then I really like it because it kind of makes the application like not aware of the monitoring system, whereas in the past you had to have like special, if statements to like not send metrics when you're developing and things like that. You don't really need that here. You can just set up your Prometheus instrumentation and it's none the wiser really. The trade-offs are the instrumentation setup is a little bit harder. It's not as easy as things like Stats-D, where it's literally just one line, you're sending a UDP packet to like a collector somewhere. The Prometheus instrumentation is a little bit more involved, and generally you probably want a library to help you with that. And then obviously once off jobs, you can't really scrape them, so you need a separate component to deal with that. So logs versus metrics. So Prometheus is firmly in the metrics camp, but does not handle logs at all. I think there's another project from Grafana, I forget his name. I think it's called Loki, that's kind of trying to do the same thing that Prometheus does with metrics with logs. But Prometheus is really all about metrics. And the difference between logs and metrics is logs are typically discrete events in time, and metrics are aggregations of those events. So you can see like the two GET requests, they get aggregated into a count of 2. Right, these are HTTP requests again. And metrics can generally be derived from logs, but you can't go the other way because there's some data lost in that sort of aggregation process. The kryptonite for logs tends to be that they just cost a lot of money to store eventually, especially at scale, because yeah, even though storage is cheap, the sheer amount of data that you get from logging is just overwhelming. And the problem with metrics, as we'll come to see, is cardinality. Metrics also tend to be better for things like alerting, whereas because logs, you typically would have to go through an ALK stack and do a complex distributed query, which might not be reliable, whereas metrics, you're just sort of querying the in-memory data structures of Prometheus, and that makes it quite reliable. So this is the anatomy of a metric. Prometheus metric in particular has a name, it has some labels like the status and the method at the bottom. Then it has a time, which Prometheus captures as it scrapes, so it just inserts a timestamp. So the metric itself doesn't have the timestamp. And then the value, which is, in this case, the count of the HTTP requests. So the thing to note is that the expensive part is the labels, because we'll come to see that's what causes metrics to cost a lot of money and a lot of resources. Whereas the time and the value are quite cheap because most of the values are integers, or not integers, but numbers, and they compress well, and you've got all the nice properties of mathematics to help you out there. We move on now to cardinality, which is really the thorn on Prometheus' side. It's actually a problem for all time series databases in general, but the bigger ones tend to handle this a bit better. But it's always ultimately limitation. If you go to the Prometheus site, you'll see this warning, which says don't add labels which store dimensions with high cardinality, which means many different label values, such as user IDs, email addresses, or other unbound sets of values. And if you go to the maintainer of Prometheus, one of the maintainers, I think, he has a consultancy and they have a blog, and one of the blog posts was cardinality is key. And I think this line here where he says Prometheus almost always comes down to one thing, label cardinality. And I think this is, if there's something you could take away from the talk, it would be this really. But of course, when you're starting out, you don't really know what any of this means, and that causes you to make mistakes, I guess. So let's take a look at cardinality. So imagine you've got HTTP requests again, and there were 7 200s and 1 500. So what would the cardinality for that look like? It's really simple. Prometheus will basically store every distinct combination of labels as a single time series. So in this case, we only have status. So it'll just be status equals 200 and status equals 500. Those will be separate blocks. And then we'll just write each value I think each one ends up being an individual file, but it's probably a bit more complicated. But for simplification purposes, you can think of it as writing to a single file for each of these. And then if you go one step further, you add now add the HTTP verbs. Then you see now suddenly you've got, so we're only using get and post here and then 200 and 500. Now you've got 4 files that you need to write to. And then now you can imagine you add something like user ID. And user IDs are typically unbound sets because they're often UUIDs or things like that. And you can imagine it just becomes the cardinality explosion. So for every single value of your user ID, you also need to have every status and every HTTP verb. And maybe if you're running on Kubernetes or something, that'll include pod IDs and namespaces and instance IDs and things like that. And you can see it just starts ballooning after a while. So that's why they really warn you against having like an unbounded set. The other thing to note that's really, really important to note is that it's active time series that matters, not all time series. So And that's really the number of distinct label values for a particular label. So imagine you had, I don't know, 1 million users, right? But for some reason your site is really unpopular and you only have like 1,000 actual like people using it during your retention window. So now say that's like a week. So you have 1,000 active users within the week. Then basically the user ID is not going to be a problem really, because it's going to be maybe a couple of 10K time series, but it's not like it's all million of the users, because obviously you only keep the data for a week, and if there's only 1,000 users using it in that week, then the following week it's just that's going to be dropped, the old time series. So always remember it's active time series, and this is particularly important to think about with infrastructure, because a lot of the things, they are technically unbound sets, like pod IDs, for example, or instance IDs. These are always going to be random, but it's okay because we know we're not going to be spinning up like thousands and millions of pods, hopefully during the retention period that we're storing our data for. Okay, and that brings me to a demo. So I'm just going to switch screens. Just tell me if you can see this. Can you guys see my screen?
Yep, we can see it.
Cool. So basically, this is a local Grafana I'm running. I've got basically Prometheus running, Grafana running, and then I've got a demo app that I'm going to show. The app itself, I hope this is legible. I've zoomed in a little bit. It's a really simple app. It just shows kind of roughly how you instrument Prometheus. So it's 2 libraries that you basically pull in. I mean, 1 library, but two packages that you put in. And then basically Prometheus does a lot of the hard work for you, but if you didn't have a library, I think this would be a little bit more complicated. So there's the Prometheus handler, and then you register each of the metrics. Here's the actual metric that I'm registering. Here's the various labels that I'm adding. So I'm adding method, path, and status. And then I'm basically looping through and just simulating like a bunch of HTTP requests happening. It's just doing the count of them right now. And then in the second file,
Oliver,
the only thing that's...
Sorry, real quick. Oliver, can you increase the font size?
Oh, sure. Up a little bit more. Whoa. Is that fine? I should probably just use foam or something, but...
Yeah, that's good. Thank you.
Is that cool? Okay. So yeah, the only difference is with the second version is that I'm just adding a user ID to show kind of... The point of the demo is to show what happens when you add like a user ID to everything, which is over here. And then instead of choosing it from like a bounded set of things, I'm just creating a new UID each time. So we'll see what happens. But before I jump to that, I just want to show you quickly the Prometheus console. So you can see this is the basic console, and for example, if I wanted to look at like Prometheus memory, I can query the Prometheus memory bytes, and this is a counter of all the bytes, right? And then I can graph that. So you kind of get a lot just by installing Prometheus. Like you can really look at your metrics and explore them. And then if you click on status and you go to targets, then you can see like, okay, here's the target. And this is what I was talking about with the server status to see if it's up or down. You can see it's down immediately because Prometheus is like going out and looking for the service, and this will turn to up now when I turn it on. Okay, so what I'm going to do now is notice that the time series here, it's around about 514. So this is basically, if you look at the Grafana query, it's just, there's this metric Prometheus TSP head series, and this is apparently just a count of all the time series in the active time series. And then this is just the count of the HP request, and this is just the Prometheus memory, which you can see is just on 94 megs at the moment, not using much at all. So the first thing I'm going to do is just, in the background, I'm just going to run the first Go program and pray to the demo gods. And now if I go here, it should turn to up. See, it's gone to up now. And if I look at my Grafana, I should be getting some HTTP requests starting over here. So it's, yeah, so it's going to be quite a lot of them because I'm purposely trying to simulate things being quite stressful. But you can see the memory is kind of staying like constant, right? So that it's doing a shit ton of HTTP requests. And the time series, you can see it initially it increases a little bit. So I remember it was like 540, now it's on 619. So the initial 514 is just because Prometheus scrapes itself as well. So that's all its time series and metrics. But you can see, so it's increasing to around 619. Memory is still pretty much flat. So this is typically what you want when you're running Prometheus. You want kind of like a bounded set of time series. You don't want it to be like increasing, should generally just be flat, maybe increase a little bit, but then go down again later on. And then your memory pretty much just doesn't really use a lot of memory. So now I'm going to run the second program, so now imagine your product guy or something says we need to track users. So you naively add the user ID. I will see what happens. So initially it's going to drop because now the count is going to reset. This is just the count of the HTTP requests. And then we should see it kind of explode. There we go. So now we're already on 12,000 time series. Now notice the memory starts climbing as well, right? I'll probably have to turn this off before it crashes my PC or something, but I'll run it for a little bit. So notice now basically, also you can actually visit the endpoint. This is what I'm talking about with debugging metrics. And you can see these are like, it's literally just a plain text format that this is what Prometheus actually scraped, so I can actually go and look at like some of the metrics. So you see it's just creating a ton of time series. And in fact, every one of these is going to be a different file on disk being written to basically. And all of these also need to be stored in memory temporarily so that Prometheus can flush to disk. So that's why the memory is going up, because it's just having to store all those distinct time series in memory. So now we're only on 60,000. You can see RAM's already climbed. RAM's basically doubled. And see, now it's now up to 400 almost. So I'm probably going to turn this off before it gets too crazy, but you get the point, right? So as the time series increases, like your memory just basically increases along with it. So that's why the secret to getting Prometheus to behave itself is just to make sure that you manage your time series correctly. And the main takeaway from this part of the demo is just don't use user IDs or things that you know that are going to be unbounded in your retention period. Okay, so I'm going to stop this quick. Yeah, so that brings me to the next part of the talk, which is basically how we halved memory consumption and doubled retention. So I'm just kind of drilling incarnates the whole time because that's really the secret to everything. Just check my notes quick. Okay. Oh, there's one quick thing I just wanted to show you. If you look at the targets, if you hover over here, you'll see there's these underscores are basically things they're called meta labels basically. And basically when Prometheus scrapes your application and it calls that metrics endpoint, basically it knows, obviously if you're on Kubernetes or whatever other system you're running, it knows like, for example, the pod ID and the namespace and all the things. Your application knows nothing about that. So it's not being included in the labels that are coming out of your app. Like if you look at it, there's no like any extra labels. So what Prometheus does is it actually has meta labels that you can add. This one doesn't look like it has much, but basically on a Kubernetes cluster, you'd see things like pod and namespace and service name. And those are all things that Prometheus can add for you to the metric. It's also important to bear in mind that lots of systems that you're going to be using for Prometheus to get data in, like node exporter and all those things, don't actually have, you're not in control of the labels that they add, basically. So I just want you to bear that in mind. So if it's only your applications sending labels, then sure, you can control everything, but usually like you're under the mercy of whatever third-party systems you're using and their exporters. And that's something that's important to keep in mind. So the problem we were running into was, so we're not really running any huge nodes because we don't really need to. So most of our nodes are just we run on Google Cloud on the managed Google Kubernetes engine. And most of our nodes are these sort of small N1 standard 2 with 2 cores and around 8 gigs of memory. And what we were experiencing with Prometheus was frequent out of memory errors and just getting killed because obviously it breaches this memory limit pretty easily. And also there's other things running on each node. It's not just Prometheus. We also ran out of disk space twice. Initially it was provisioned for 20 gigs and then 50 gigs, and both times it ran out of memory. Ran out of disk space. Didn't really make sense to us because we don't really have like significant traffic on that cluster. There's around 12 nodes, but that's not like huge. And we also wanted to really double our retention time for business reasons. And yeah, we couldn't even manage on 15 days at that point. So this is, I don't know if you've ever seen the DNS haiku meme, but this one's particularly true for Cardinality and Prometheus. So it's a similar thing. So it's basically always Cardinality. I don't know if you know that house meme. It's never lupus. This is the opposite. It's always Cardinality. So basically, if you look at the way we run our systems, each of our clients gets their own Kubernetes namespace, which is typically also tied to their own subdomain. The end-to-end tests that we run to test everything's working typically create random test namespaces, like test 42 ABC. And if you couple that with the fact that whenever you spin up a namespace, you also spin up a whole bunch of pods, and all of those pods have random names, you end up with a cardinality explosion, basically. And almost all the metrics in our system obviously have the namespace where they're coming from. So they all have this like random string in them. So basically I noticed that, whenever we would run or have our end-to-end test runs, that the time series would go up at the same time. So the first thing you can do is basically there's a nice query you can run to check your top, whatever most expensive metrics. So that's the first thing I did, and I noticed there were a couple of Nginx controller type things. There was an API server, which is the Kubernetes, I think it's the Kubernetes API server measuring the request latency, and a few other like minor things, but the bulk of it was these Nginx ones. So then I went through each one and I started just looking at the basically how many distinct labels were added by the random test namespaces, basically. So you can run this second query here, which is just counting them. And then basically I just populated this by hand manually because it was like only 15 or so. And then what I found at the end was basically that 75% of the time series are basically due to these test namespaces. So we had about 830,000 time series, and basically most of them were just due to the like random test namespaces being spun up, which isn't great. And another thing to note, which is interesting, is that it's really dominated by histograms. Whenever you see the word bucket, typically in metrics, that means it's a histogram. So the problem with histograms is basically that they add a whole bunch of extra labels. So the way that it does basically makes the buckets is it just adds a label for each bucket. And if you look at, for example, I don't have the example of that, but the one for the Kubernetes API server is actually pretty crazy. I think it's got like 20 labels or something, just to all the different buckets. So basically just gives you like a ridiculous amount of cardinality if you combine it already on all your other labels that you probably want to have. So my advice is just to be careful of histograms and just don't just use too many of them in your applications, because you probably will get a huge cardinality explosion happening. So onto the fixing strategy. So what can we do about this? So all you can do really is reduce the number of active time series, right? If that's the only thing you can pretty much do to make Prometheus use less memory and less disk space. So we obviously We can do that by reducing the retention time, but obviously we can't do that because the business actually wants 30 days, not 15. So we can't reduce the retention time. We can remove expensive labels from our applications, but really our apps are behaving. We kind of listened to that cardinality thing early on and took the warning seriously. So we didn't really have any apps that were like using anything random in their labels or any unbound sets there. So the only thing left to do really is to relabel in order to drop the expensive metrics and or labels. So that's a strategy we end up going with. So here's an example of a Prometheus config. It looks a bit scary when you first look at it, but it's actually quite straightforward. So basically, you've got two key things here, which is the first one is relabel configs, and the second one is metric relabel configs. And they're kind of named a bit confusingly. But really, the first one is just to firstly figure out which targets actually get scraped. You can see basically what this is saying is that, sorry. This is basically saying basically only scrape services that have this particular annotation. And then the second thing relabeling does, the first relabeling does, is it lets you choose which meta labels, remember that I talked about, get chosen. So this is like saying keep the service name, and then you can also rename it to something else. So the important thing to bear in mind with relabel configs is basically it works before scraping, before the metrics are actually scraped, right? And then the second one, metric relabel configs, is basically what happens after the metrics are scraped. So this lets you like drop metrics or drop labels. And that's exactly what I'm doing here. So I'm dropping the expensive metrics first. So basically looking at the namespace, the namespace labels, dropping anything that has test in it, looking for the host in Nginx ingress, and dropping, because basically the subdomains that I talked about for the client namespaces, they get their own namespace and they get their own subdomain, and that also unfortunately have this random string in it. So I dropped that, and then these last ones here, the CM Acme HTTP solver, we use something called Cert Manager to do Let's Encrypt certificates. And the way it works is for HTTP resolution, it spins up a whole bunch of pods with random names to resolve the challenge request from Let's Encrypt. So those we also don't really care about because they basically just spun up and spun down again. And then the last one is just drop expensive labels. So I'm just removing certain labels like instance and all these weird controller .star metrics from Nginx ingress, I think has them. So yeah. So basically after relabeling, we got a huge reduction in time series. Basically it ended up settling on around 350,000 time series. And that's with doubling the retention, because at that point we realized we could just double it at that point because it was using so little time series anyway. And around that time we also got a couple of extra nodes added to the cluster, so it's kind of nice to see that the time series was settling on such a low number. Memory usage went down from 45 gigs to about 2, and bear in mind that the 45 was with 15 days only. So 30 days probably would have consumed significantly more memory. There were no more out of memory kills. Disk space also went down. It's now using about half of what it used before. And it hasn't been down since, basically. Here's a little bonus, like how not to run out of disk space. I should have done this initially when I said Prometheus. It was a mistake on my part. Basically, I read a blog post about this, and they say you can measure the amount of disk space used with this formula, which is basically the bytes per sample, the ingestion rate, the retention time, and then a little bit of buffer for some other things that the calculation doesn't take into account. And you can get basically the bytes per sample by running this query, and then you can get the ingestion rate running the second query there. And that will give you a pretty accurate number for how much space Prometheus is going to need for your retention window. And then for even better alerting, Prometheus has this nice predict linear function, which actually lets you, it does like a linear regression against your, I think it's your, you can do it on whatever you're monitoring. If you're looking at the Prometheus disk space, you can just plug in the disk space into predict linear, and then you give it like a time range, and it'll tell you like in, I don't know, like a day, what will the value be based on the current slope of the graph. So that's a nice way to alert That seems to work pretty well. And you can use this for a lot of other things as well, but I think it's quite nice for disk space. So yeah, main takeaway with Prometheus is cardinality is Prometheus's kryptonite. And it's really the kryptonite for all time series databases to some extent, although some handle them better than others. But with Prometheus, if you want to run a lead Prometheus, keep your time series low, keep your active time series low. And yeah, here's some resources. And yeah, that's about it.
All right, that's it. Oliver, thanks. Any questions? Do you have any questions on Slido, Shara? Let me check.
So far, none. But for those who haven't seen the link yet on the chat, again, if you have a question that you'd like to ask, you can go to slido.com and enter the code GoManila.
Yeah. Charo, do you have any questions, or Johnny is in the background at the moment while we're waiting if people are gonna actually ask? Oh, no one. None? I see Ben is in our attendee Zoom. It's an attendee in our Zoom. Do you have any question, Ben? Hey. We also have Lawrence and William. If you guys have any questions, yeah, you can. Don't want to write it on slide. You can write it straight on our Zoom chat. Huh. Okay, so I guess there's none. All right. Yeah. Okay. So, what do you want to do, Charo?
Well, right now, there are no questions. There's still no questions here on Slido.
Yeah. So that's fine, I guess.
Yeah.
So I think that's they can. Do you have somewhere they can contact you, Oliver, if they have questions?
Yeah, they could tweet at me. I think I put it
Give
in
a
the
Twitter
first slide.
or yeah. Oh, Ben's asking Oliver on our chat, when would you not use Prometheus?
I wouldn't use Prometheus if I needed like serious performance, I guess. Yeah, there seems to be actually going to start experimenting with something called Victoria metrics. Maybe I'm going to try and get that going. But there seem to be a lot of time series databases now, like Victoria metrics and timescale data DB and stuff like that, which seem to significantly outperform Prometheus. But to be fair, I think they're a bit more complex and probably not as easy to run as a single binary and things like that. Although Victoria metrics looks like a drop-in replacement, and that seems to promise like 10 times the performance of Prometheus. But generally, if you need higher cardinality than Prometheus can offer, then or like really fast ingestion rates, then you probably can't use Prometheus. But there are also big companies that use it, like Monzo, and they use Prometheus for something called Thanos, which kind of adds like a sidecar to each of your things, and it's a way to like sort of combine a whole bunch of, I'm not going to say the plural Prometheuses, I'm just going to say Prometheuses, together and just have like one big aggregate for you. So I'd probably look into doing something like that, but most likely just swap it out to some other system, I guess. Or you can always just keep Prometheus, but feed it to like a bigger system for. So I have a lot of like smaller Prometheus and then feed it to like something like InfluxDB or Timescale or Victoria Metrics. That's another option.
There's also another question on Slido, our first question, actually only question. So how do you identify the hardware needs? I think he's talking about to run Prometheus basically. I guess how would you go about identifying what the hardware requirements are
I guess
based
it's
on the
just
specific setup?
based on it really depends on, I guess, like how many nodes you have, what sort of cardinality of data you're expecting. But for a smaller system, like we're running about 12 nodes. It's not huge, but and we're doing that with 2 gigs of RAM. So I really think Prometheus can actually handle quite a lot if you just very bear in mind the cardinality warnings that I said. It's really just about keeping your total time series low. And most systems, I think, when you're monitoring your ingestion rates, aren't like crazy. So you should be able to get away with like running on like under 8 gigs of RAM. I would say should serve a lot of most people's needs, I would think. But you can use all the stuff in the talk just to figure out like and debug things. Oh, and there's also there's a blog post which I don't have now, but you can look it up. It's basically got a calculator for how to figure out how much memory you need based on your retention window, and it's basically got like a little calculator. I'll try and find it and link it somewhere.
Okay. Are there any other questions from the attendees on the Zoom call or people watching the YouTube live stream? You can ask us Slido. There are none. No one? Anyone on,
No questions on YouTube so far.
and also no questions on Slido. Okay, so I guess that's it for tonight. Thanks for the talk, Oliver. Appreciate it.
Pleasure. I got the
Alright.
link, by the way, if I should paste it somewhere, but yeah, I'll just send it to you after.
Yep. Paste it here, and then we'll probably add it to the YouTube description or something, like on the description of the video.
Okay, cool.
Got it. All right. Thank you. So thanks again, everyone, for attending GoManila. Thank you very much to our speaker for tonight, Oliver. Thanks, Shara. Thanks, Johnny. So by the way, I guess I would just like to promote. So one of the products that we've recently launched in Brankas is called Brankas Pay. Let me just quickly share my screen. Share my desktop here. Just real quick. Yeah. So can you see my desktop? Is it being shared? Cool.
Yep,
Yeah. So Brankas Pay is it's a super simple bank transfer. Super simple way to accept bank transfer as payments for online micro and small merchants. So people selling on Facebook, Instagram, and whatnot, right? So we've launched it here in the Philippines first, but we are launching soon in Indonesia and other Southeast Asian countries. So if you're in the Philippines, you have a BDO BPI bank account, please feel free to sign up for our early access. We've already done 2 batches of for our private beta testers. And if you don't have a use case for this yourself, maybe you know someone, maybe you have a friend who's trying to get some extra cash, or trying to start up a small online selling business, and in this time of COVID, as we all know, everyone is trying to get by, everyone's struggling, and they need a way to systematically accept bank transfers for payments. You can send them our way, and we can set them up with a pay account. Basically that's it from us. Thank you so much, and see you again on the next GoManila. Bye, guys.
Cheers, guys.
Thanks.